Hello, my name is Audrey Munger, and this is my lab report for Physics 2211 on constant velocity. For my lab report, I will first go over some main ideas regarding Newton's second law and how it relates to some of the equations we have learned in class. I'll also discuss the materials I used to do this lab, how I used the tracker application to show my data, and how I use the GlowScript starter code to make a projected model of my ping pong ball's motion. Then I'll make a graph that compares the data from Tracker and GlowScript to each other. This lab uses Newton's second law, the momentum principle, to demonstrate an object moving at a constant velocity, meaning no change in speed or direction. I used a ping pong ball rolling horizontally across a table in my experiment. Newton's second law states that forces acting on a system from its surroundings cause changes in the system's momentum over a certain period of time. If the forces remain constant, there is no change in momentum and the velocity is constant. Here I have two related equations from lecture. First I have the momentum principle, showing that the change in momentum divided by the change in time is equal to the net forces on the system. I also have the momentum update formula on the right, which is used for calculations when there has been a change in momentum of the system. For my lab procedure, first I recorded the motion of the ping pong ball as it rolled across the table. Secondly, I put the video into Tracker and tracked the ball's motion as time progressed. Next, I used the GlowScript starter code and some of my initial data from Tracker to create a model of the ping pong ball's motion. Lastly, I made position versus time graphs with the data collected from Tracker and compared it to the ones I had made on GlowScript. To demonstrate constant velocity, I rolled my ping pong ball across a small table and put it next to a tape measure to use as a distance reference. Using Tracker's settings, I collected data only from when the ball was no longer in contact with my hand and before it reached the end of the table to avoid additional external forces. Based on where I set my axes, my initial position was found to be 0.578 millimeters to the left in the x direction. The initial velocity was also found to be negative 0.168 meters per second to the left, which was calculated from 1/30th of a second, which is the change in time of each frame in the video. I added in these initial position and velocity values from Tracker into the GlowScript starter code. I also set delta t equal to 1/30th of a second because this is the time between each new frame in the video. Here are the position versus time graphs I got from Tracker on the left and GlowScript on the right. As you can see, the graphs are fairly similar, both showing a constant change in position versus time and a downward sloping curve. This is due to the way I set my axes on Tracker, with the ping pong ball initially moving away and to the left, which is the negative direction of the origin. I took the data from Tracker and GlowScript and put them into Google Sheets so that I could create a graph that overlaps the two for comparison. From this graph, I can see that the GlowScript data is moving away from the origin at a faster rate than the Tracker data. The GlowScript data is created off of the initial velocity in the first frame, so this could be due to issues in calculating that velocity. I could have set the first frame when the ping pong ball was still touching my hand, so it is possible that the initial velocity had an additional external force acting on it to make the ball move a little bit faster. Positive x and negative x could be interchanged if I had changed my orientation of the axes on Tracker from the ball moving away to the left to it moving away to the right. This would cause my graphs to be sloping upwards rather than be sloping downwards, but they would still have a constant change in position versus time. It is impossible to tell the number of pushes and pulls that create the net force of 0 in this experiment. This is because we do not know the frictional force on the table I used, or the air resistance in my apartment.